Okay, in last sections, okay, you learn about the counting process, the permutations and the combinations. Okay, and in this section, we will see the how we calculate or compute the probability values. A probability values of an event E is always equal to small n divided by the big N. Small n's, like for example, if we use the case of dice, what is the probability for you to get one value of one? So there is only one side give one value of one, and in total there are six possible values, possible outcomes. So that's why the probability value of getting a ones when you toss a dice is equal to 1 over 6. And for all definition 2.8, for any probability of an event, it must be either equal or greater than 0. Okay, so the sum of the probability of a mutually exclusive is equal to 1. So you can use the case of dice. So we have PE1, PE2 until plus PE6. So when you add up all, 1 over 6, 1 over 6, 6 times, you must get equal to 1. So and definition 2.9, consider any mutually exclusive event, say EI and EJ. So means that these two events, they don't have possible outcomes. They don't have common possible outcomes. So when we say the probability of an event, a union of an event EI union EJ, it will be equal to PEI plus PEJ. So because of these two are mutually exclusive, they don't have common possible outcomes. So now we look at example 2.2 for very straightforward example. There are 25 vans, 10 lorries, 10 cars, and 8 motorcycles were caught in the traffic jams. If a vehicle is randomly selected, find the probability that the vehicle chosen is a van A, B, a motorcycle, or a car. So for A, a van, so we have in total there are 53 vehicles, and out of these 53, 25 are vans. So what is the probability you will get a vans? So the answer is equal to 25 over 53. So B, a motorcycle or a car, we have 8 motorcycles and 10 car. So that's why 10 plus 8 is 18. The answer is 18 divided by 53. Okay, the next example, you have 5 cards. Find the probability of holding 2 aces and 3 z. So now we have to find how many way, the number of way being dealt 2 aces from 4. So you have 4 aces. So what's his number? Because these 4 are not the same in color and also the patterns. So decide what is the number of way for you to choose any of two of from these 4. So that's why it is 4C2. So 4C2, then you know that there are 6 way. If you don't believe that you can arrange in probability tree, then you will understand that why the answer is equal to 6. So now, we also have to find the number of way to get 3z out of 4. Because they are not the same, there are 4z, they look very different in color and types. So that's why it's 4C3. The answer is 4. So when because of we want to have two aces and 3j, so that's why multiply them. Okay, so 6 multiplied with 4, you get 24. So this is a small n, and for the big n, so means that there are 52 cards. You add for what is the number of any combinations, Okay, 52 we want to get 5. How many way? So the answer, if you get 52C5, then you will get very big figures. Then you put into the probability value equation, you get the answer which is very small. 24 divided by 2598960. Okay, so a coin is tossed twice. So you have one coin, you toss 2 times. So you are then you list down what is the all possible outcome. If you look at the S you represent all possible outcome. We may get HT, TH, and TT. Because of you use one coin and you toss 3 times, that's why HT and TH are not the same. So means that altogether there are 4 possible outcomes. This is our big N values. So now, what is the probability that at least one hit occurs? So because of this is a balanced case, so we use a normal coin, not cheating. So that's why at least one hit, we have 1, 2, 3. So the answer is 3 over 4. So means that at least one hit. Okay, so 1, 2, 3, then 3 over 4. Okay. So now, okay, we come to another example. This example is a bit tricky. A dice, we're talking dice, is tossed in such a way that even numbers is twice as likely to occur as an odd numbers. Okay, so what does it mean? Okay, if you use a normal dice, so you will list down 1, 2, 3, 4, 5, 6. But now this dice is not a normal dice. It's not a normal dice. It's a very special dice. It tells you that, okay, the chances for you to get even numbers is 2 times higher than the odd numbers. So means that, okay, you will get 1, 1, 2, 2, 1, 3, 2, 4, 1, 5, and 2, 6. So, okay, if you count, okay, the total possible object is not 9, is not 6, but it becomes 9. Because I say you can have 1, 1, but 2 you have 2 times 2, because of you want to make sure that the even number is higher than the odd number 2 times. So that's why you get the answer is, okay, 1, 1, 2, 2, 1, 3, 2, 4, 1, 5, and 2, 6. If you count, there are 9. So that's why if ask the question asks if E is the event that a number less than 4 occurs on a single toss. Less than 4 means that it's 3 to 1. So 3 to 1, so it's 1, 3, 2, 2, and 1, 1. So that's why it's 4. So 4 divided by 9, then you get answer is 4 over 9 for the answer of these examples. Okay, so now, okay, continues as the extend the previous examples. Okay, now we say let A be the event that an even number turn up, and B let B be the event that now a number divisible by 3. Okay, so turn up, A is even numbers, B is you get 3 or you get 6. So either ones, 3 or 6. So now, okay, you want to find two conditions, probability A or B. So A or B means that you have to merge A and B together. So you have 2, 3, 4, 6. A and B is 2, 3, 4, 6. So 2, 3, 4, 6, what is the probabilities? The probability, because of you have, okay, 209 for 2, 109 for 3, 209 for 4, and 209 for 6. So the answer is 709. But for another one, A and B, A and B. So A and B, what is the common elements? There is only one. There is only 6. Is it? Okay, 6. So there's a 6 is 2 times. So 2 over 9. So A and B, okay, the common element is 6. So the answer is 2 over 9. Okay, example 2.29. An indoor car park has 5 cars labeled as 1, 2 to 5. 1, 2, 3, 4, 5. Suppose we select 2 cars in succession without replacements. Okay, no repetitions. How many distinct orders are possible? Pair are possible. So the answer is, okay, you still remembers? Okay, is NCR. So first choice is you have 5 choices. First draw you have 5 choices. So that's why it's 5. So 1 is selected, then you only have 4. 1 is the choices for the second draw is 4. That's why it's 5 multiplied with 4, which is equal to 20. So now, okay, the second section part of the question is, what is the probability that the first car has a number larger than the second ones? So then there's no shortcut for this one. We have to list out all possibilities. So now you see B, 2, 1, 3, 2, 3, 1, all, okay, all possible outcome is the first number is larger than the second numbers. How many of them? There are 10. So that's why the answer for the second part of the question is equal to 10 over 20. Okay, I like these examples, very tricky examples. Okay, is it tricky? Once you understand, you will think that it's quite easy. So now, suppose that 12 cars are placed randoms into parking lots, where more than one car is allowed to occupy a parking lot. What is the probability that all parking lots are occupied? Okay, first of all, don't argue with me whether this question is logic or not. Okay, because of one parking lot from transportation's point of view, one car park is only can only occupy at most one vehicles. So, but this is something special. Okay, so now you have 12 car and you want to park into 12 parking lot. So, but you are allowed to park more than one car at the same parking lot. So now the question asks, what is the probability all parking lot are occupied? So now we have to find the probability is equal to small n and divide by big N. So now we find what is the value of big N. So what big N is all possible way to arrange the vehicles. Okay, all possible way to arrange vehicles. So you can imagine, okay, you have 12 car in your hand. In front of you there are 12 parking lots. So when you go to the first parking lot, how many way you can choose one car and put into the first parking lot? There are 12 way. Okay, 12 way. So now when you move to the second parking lot, as question say, you can park, okay, you can park more than one car. That's why, okay, when you go move to the second one, you still have 12 cars in your hand. So that's why when you move from car park 1, car park 2, and until car park number 12, you have 12 way, 12 way, 12 way, 12 times. So that's why the big N value is 12 power of 12. But the question asks you, what is the probability that all parking lot are occupied? So means that none of the parking lot is empty. So now for you to find the small n, when you come to the first car park, you have 12 car in your hand, so that's why you have 12 choices. So you have to make sure that, okay, when you come to this, you have to make sure that all car parking lot is occupied. So when you come to the second car park, you have to park. You already have parked one car in the first car park, so it means that you only have 11 car in your hand. So when you move to the second car park, you only have 11 choices, 10 choices, 9 choices, 8 choices, until when you come to the last one, you only have one car in your hand. So that's why it's 12 factorial. 12 multiplied with 11 multiplied with 10 and so on. So that's why it's equal to 12 factorial. So now this is how we build the answers.